Hello, this is PTTGRW, and welcome to your tutorial on how to add resources to the Kethane plugin, in which it'll allow us to generate them in the world on planets of our choosing. In this video, I'm going to go over how to define a resource in KSP, how to make that resource a Kethane resource, and then how to generate the Kethane resource into the KSP world. Also, I will be going over how to modify the current Kethane parts, such as the small drill, the scanner, and the converter, so that we can convert our new resource. To get started, let's create a new config file for the resources. We're just going to go into our custom configs folder and just going to copy this and paste it, but we'll edit what's inside. First off, I'm going to rename it to resources because this is where we're going to be putting our custom resources into the world. Open this up, drag it over here. Don't need any of this. Okay, just a faster way to get this. Now, what we're going to look at is something that is called resource definition. Now, this is what KSP uses to define what the resources are. And this is put into the curly braces. Now, resource definition, when this is called, what we're looking at is we're looking for a name, a density, a flow mode, transfer parameters, and if it's tweakable. Now, this is all that goes inside a resource definition. Now, resource definition, the name is what it's called. For example, liquid fuel is this, just liquid fuel. But we're going to create a custom liquid that we can mine on the moon. So we will just call ours liquid moon, and you can put a space here, it doesn't matter. The way when it reads the name of this, it's going to read whatever is past this equal sign. So the space will not mess with it. You don't have to put an underscore, you just name it whatever you need. Now, the density. Liquid fuel's density is 0.005. The higher the density, the heavier it is when the container is full. So I believe Kethane is at 0.002. Let me just check on that real fast. Yes, Kethane is 0.002. So there's just kind of a comparison. But liquid moon, we're going to have this actually be more. We're going to have this be twice the density of liquid fuel. Now, flow mode. There are a couple different types of flow mode. Liquid fuel and oxidizer have the mode called stack priority search. What this means is it's going to basically, if there's a same fuel tank below it, then it's going to drop the fuel into it. It's going to automatically flow down below. Now, another type of flow mode is no flow. And we see this in solid rocket boosters because you can't move the resource and it doesn't flow anywhere. Now, electric charge and monopropellant use something called all vessel. Now, all vessel is what we're going to be using for this resource, and this means the entire vessel can use it anywhere. It doesn't matter. Now, the transfer type. There are a couple of these. You have pump, which is just the standard. You have to pump it in between different containers. And you have none. Now, SRBs use none because you can't transfer the solid fuel anywhere. But all of the other resources that are added from stock KSP use pump. So we will be using the same for this. And is tweakable. This means, can we tweak the amount of the resource inside of the VAB? And most of these are set to true, or it's actually lowercase this time. If we want it to be true, then that means we can edit how much of the resource is in the container. However, since this is going to be a Kethane resource, we don't want any of it to actually be in the we don't want to be able to put it inside our fuel tanks in the VAB. We want to have to mine it. So we can either set this to false, or we can just leave it out entirely. It will automatically set itself to false, so we don't need that. Now, this is defining our resource. Next, what we are going to have to do to create a Kethane resource is give it a tank definition. Now, you're going to need Module Manager for this, so make sure you have that installed, and we need to do @tank definition. And we're just going to be using default and curly braces as always. Now, what we do here is we create a new tank definition, as what it would imply, where we just go tank, curly brace, end brace. And inside here, we tell what resource we're changing. Name equals liquid moon, and fillable. Now, fillable can be set to a couple of different things, such as false, which is what we're going to be using. We're going to set it to false because this basically says the tank that contains, or any tank, the default tanks, cannot hold liquid moon. They cannot be filled with it. Now, we set it this way so you don't start with it. You don't start with them full, like with the liquid fuel or oxidizer. Those fuel tanks will start 100% full when you select them and put them into the VAB to build with them. But setting this to false will say that it can't be full. Now, in the tank definition default, we can set as many of these as we want. You just end the curly brace and you can put another tank type, so if you have multiple resources you can put them all in the same @tank definition. But now that we're done with this, we're going to actually get into the Kethane resource. So make sure we're outside all of our curly brackets, and Kethane resource is what we need to call next. Now, this, as all things, will take a couple of brackets. They just define where our code is. Now, the first thing you're going to need is resource. You're going to need color full, color empty, and these are the three parts of the Kethane resource. Now, resource is just the name, and our name is liquid moon. That's it. Now, the color full. This is for when you're looking at the map view. So when you have the map view up and you're viewing all of the hexagons, they have a different color. Kethane uses a green color. Now, what we're going to use for this is we will use blue for the full, and these are RGB values, so it takes 3. So we're going to just have 0 red, 0 green, and 1 blue. This will be a pure blue color. As for color empty, we're going to have it to be red. So we're going to have 1, 0, and 0. Red, blue, or red, green, and blue, RGB. Now, inside of this bracket, we haven't put an end one yet, we need to actually define the generator. So we call generator, and as all things, we need more brackets. And it is very important, by the way, I might mention, it's very important you put these brackets in the right places, because if you have things that are not contained within the right brackets, the right pair of them, then none of this will work. So we have generator, and for this we need to call name min radius min quantity, or excuse me, I missed one, max radius min quantity max quantity min vertices max vertices deposit count number of tries, and this is, well, there's one more, min vertices max radius variance, and I'm setting this up just like the standard Kethane definition, so it will look familiar if you do check out the source code. And radius variance. Now what we need to do for all these is, this is the generator, and these all need to be assigned something. Name. Now the name has to be legacy resource generator, each with caps, no spaces. This will tell you that the generator we're calling is the legacy resource generator, which is from the Kethane plugin. Now I'm going to quickly pull up the values used for Kethane. Now min radius is the smallest amount of basically the size that you can have for your resources that get planted on the planet or celestial body. And standard, this is set to 7.29. Now if you reduce this, your nodes of resource are going to be smaller than Kethane, and if you increase it, they'll be larger. Since we want a little bit larger, we're going to bump this up to 9.29. Max radius is the largest size. Kethane uses 16.2, but we are going to use 22.2. Min quantity, this is the smallest amount of resource that can be in one of these nodes, and Kethane uses 10,000. But we want to have a lot of liquid moon. Since the moon is quite large, there should be a lot of it. We're going to bump this up to 100,000. And max quantity is 500,000 by default, but we're going to be using 800,000. Now you can set these numbers to whatever you want. You don't even need to keep these even. If you want any just random set of numbers, like maybe 100 and 237, you can have whatever number you want. And the larger the min, this is the smallest amount you can get, so the larger you have here will basically determine the smallest amount. So if you set your min radius to small and your max radius to very small, and then a high min quantity, you can basically create just one or two hexagons on the celestial body that contain a huge amount, basically oases of the certain resource. Now Kethane uses 20 min vertices. Now, and max vertices it uses 50. Now these numbers do affect it, and for their actual definitions is min vertices are labeled as minimum number of vertices in a deposit's shape. Vertices are distributed uniformly in a circle around the center of the deposit. Basically, this determines how jagged the resource is. If you have a high number of if these two numbers are basically close together, what's going to happen is you're going to get big circles on the planet or the celestial body. If you have these varied, like this is a 30 variance, and you go to radius variance and you set that to a high number, then you're going to get like protruding arms of the resource. They're going to kind of go out in single lengths and be more of kind of like vine-like. Instead of being a just flat circle, they just kind of extend into branches, like roots. So, getting back to it, the radius variance that is used by Kethane is 0.45. We want it to be a little more crazy than that, so we're going to use 8.5. We're also going to change the min to 26 and the max to 87. Now, deposit count is how many deposits you're going to actually find. And this is how many deposits the generator will attempt to place on the celestial body. Meaning if you have this set to only one deposit, that means on the entire moon or any planet you specify, there's going to be a single deposit that's going to range from 100,000 to 800,000, and it's going to follow all of these. If we set to 2, then it's going to have 2. 3, it'll have 3 deposits. We want it to be rather easy to find, so we're going to have it have 32 deposits. Now, the number of tries is the number of times the generator attempts to place each deposit. Because it selects a random location and shape in each attempt, it will appear more how you want it based on the higher number of tries you have. If you have more tries, then it's less likely to skip a deposit. Like we have quite a few deposits, so we're going to need quite a few tries to actually make it so it seems pretty accurate. So compensate, it's normally 30, we are going to set it to 50. Now, this is all of the definitions on how you're going to generate your resource. So, how do we tell it where we want the resources? Well, now we tell it we want it on a body. Which body? Well, actually, which body do we want these on? Well, the name of the body is the moon. And here we can define or reset the deposit count, because the deposit count is set to 32. We can change this by defining it here, and we can actually change any of these by defining it back here. So if we were to leave this out, the deposit count would be set to 32. But we can change this and tell it to be 36. We could also decide that on the moon specifically, we might want the min quantity to be higher, like 200,000. And this will reset it to that the moon only will have these parameters, and it'll use the default ones. So these are default parameters, whereas in the body, you tell the body, and then you can define extra parameters that customize each body. Like Duna, you might want it to have a lot higher iron concentration than any of the other celestial bodies in the Kerbal solar system. And to close this off, you just put an end bracket. And you can put as many bodies as you want. So even though this is liquid moon, well, Minmus is also a moon, so let's add this on Minmus, although in a lower quantity. So name equals Minmus, and Minmus is going to have less deposits, so deposit count is going to equal, we're only going to have 5 deposits on Minmus, and we're going to close this. Now this is all you need. Now we have 2 bodies set, and I'm going to give us some extra space. We have 2 bodies where our resource generates, which is liquid moon, but we need to make sure we close everything. We closed our bodies, we still need to close the generator and the Kethane Resource, so let's do that now. Close the generator and the Kethane Resource, because it's important that you close these all, otherwise things won't work. It's also highly important that you spell things right. such as deposit, there's not an E there. So if I were to leave the E there, then that would just kind of break. Although since we're defining them down here, it wouldn't matter because it'd still understand what we want. But just make sure you do spell all of these right, and I may have spelled some wrong. So I'm just going to double check my code and meet you back in the Kerbal Space Program to show you that we now have a new resource. And don't forget to save this, Control S, and I'll see you in KSP. Now that we're in KSP, I do want to point something out. When you go to start your game with the new resource config, you don't have to start a new one to get the resource. You can actually click Resume Saved, and I'll load up my previous world I've been using. And it will create the new resource. Let's go to the map here from the tracking station. And you see, we can see that we have now Liquid Moon, and there's currently no data. And also down here in the Kethane scan map, we can push the arrow and get Liquid Moon. This will allow us to view whether or not we're observing it, or if we are. And this world did not have this resource before. This was brand new to this world, because we just created it. So you don't have to restart your entire saves if you want to add new resources. You can actually allow the generator to dynamically load in the new resource without any issues. However, we haven't added any way to scan for, mine, or convert our new resource yet. So we see that it's working, which is a good step. Now we're going to have to go back and edit some more stuff. So I'll see you guys back outside. Okay, now that we are back outside of the game, we'll take a look at adding our resource so that we can scan, mine, and convert it. Although first I do need to show you a critical issue that I made a mishap on. You see how I set these numbers to 1.0? These actually, when they're set to 1.0, will cause it to be impossible to scan for the resource, meaning you cannot mine it and thus cannot convert it. So whatever I said before, these need to be at max 0.9. You can set it as many as you want. I'm going to leave it at just 0.99. But you cannot set them to 1.0, otherwise they will not work. I'm not entirely sure why, but I'm just telling you, you can't have them set to 1. Otherwise, you will not be able to scan for your resource. So we'll save that. Although there is one last thing I want to do. Since we are going to be converting our Liquid Moon, I think it's appropriate we create a new resource to convert to. So, resource, let's create a new one. And I already had an idea for a name. It seems to fit the Kerbal kind of wittiness pretty well. Let's see if you can guess it. Moonshine. Yes, that is what we'll be converting Liquid Moon to, is moonshine. And its density will be about the same as liquid fuel, or the same as liquid fuel. Flow mode is going to be all vessel, and transfer will indeed be pump. And there, since we are not generating this on the moon itself, all we need to do is say that the resource exists and set up a tank definition. And we can do this inside the same @tank definition by just putting another tank, another set of brackets, name is moonshine, and it is not fillable. There. And I'm just formatting this so it's easier to see. But we need to make sure those are 9.9, and once you're that, you can save this and close out resources. Now what we're going to need is a new file. Let's copy, paste this, rename it to custom Kethane config, open it up, delete all this stuff, save it. Okay, so the first thing we're going to need to do is scan for our kethane. And to scan for it, we need to add the high gain, or the small scanner. Now, you have to look up the part names, but the small scanner is called Kethane underscore high gain. And once we have that defined, we just put our curly braces. This is using Module Manager, so keep in mind you do need Module Manager installed for this to work. And we're going to create a new module inside of this. And this module is going to be called Kethane Detector. And we need to set a couple parameters. Detecting period, which is set to 1.5 seconds by default. Detecting height, which for the small scanner is 250,000. Power consumption, which is 0.8 electric charge per 1.5 seconds. And now we need to set what resource this scans for. And the resource we're going to be scanning for is going to be name equals liquid moon. Close this off, and we're done with this module. Now, all of this will look at the kethane, the compact scanner. It's going to add this module here, everything here. It's going to add to that part, which is the kethane detector module, and it's going to have the same scanning period, same scanning height, same power consumption, and the resource this time is going to be liquid moon. So now that we have that one all set and out of the way, don't need that, let's go on to how we're going to mine this. Well, in order to mine it, we're going to have to do the same thing. Another at part, except this part is going to be kethane underscore small drill. This is the small drill. If you want to use the large drill, you're going to have to look up the name, which you can find in the kethane folder pretty easily. But we need to add a module to this, and this module name equals kethane extractor. Now, if you have your own parts, like if you're a mod author and you have your own parts, you don't actually need to put at part. You just have to set this module or any of the modules inside of your parts config file, and it will automatically start doing this for you. Now, we also need power consumption for our drill, and by default this is equal to 8. We're going to leave it at the same amount. Resource. Now what are we trying to mine here? Well, what we're looking for is name equals liquid moon, and we also need to say what's the rate it mines. Well, by default the rate is 5.00, and we're going to leave it at default. Now, two extra things you do need to include are head transform equals shaft small underscore geo, and tail transform equals drill motor geo. Now, you only have to include these two things if you are using the kethane small drill. If you include them for anything else, it will not work. So only if you're modifying the small drill will you be using these two things. Now, let's close off all our things. Make sure this is formatted. You don't actually need all these spaces. I just put them because it makes it easier to look at, formatting reasons. Okay, now this entire module, the kethane extractor module, will start extracting the liquid moon at a rate of 5, and this will be part of the Kethane small drill. Sorry if I've been pronouncing that wrong. It's just a bad habit. Now, the last thing we need to do is convert. And for this to work, we need to call another app part using Module Manager. And this part is called the Kethane 1 meter converter. And we need to put another module in, which name equals Kethane converter. And what this one takes is this one is optional, label, which label allows you to set the name of the converter, because the converter is designed to have multiple buttons on it that allow you to convert multiple things, such as liquid fuel, oxidizer, xenon gas, and monopropellant. So you're able to label them to keep them better organized. This one, since this is going to be a liquid fuel tank and oxidizer, we'll just call it LFTO. That means it will give us liquid fuel and oxidizer. Now, aside from the label, we need to tell it what it's going to be taking. So, input rates, it's going to take liquid moon at a rate of 1 and electric charge at a rate of 2. So for every 1 liquid moon, 1 liter of liquid moon, and 2 electric charge, it is going to give us whatever we define in the output rates, which is output ratios. And for this, we're going to do what the liquid fuel and oxidizer comparison is, which is liquid fuel at a rate of 4.5 and oxidizer at a rate of 5.5. That is the fuel consumptions for both of them, so we remain even. We don't get too much liquid fuel and we don't get too much oxidizer. It's a perfect burn comparison for liquid fuel engines. And we just need to close that off. Now, I'm missing a single bracket here to close off the module. And because we created moonshine earlier, let me just copy that module in. Save us a little bit of time. Doing the exact same thing we did there. There we go. Now this one is Kethane converter, same thing, except our label is going to be moonshine, and we're going to input 1 liquid moon, 10 electric charge, and we're going to get 1 moonshine out of it. Now we just need to close. We have our modules close, and we just need to close the app part declaration. There, this is all we need, so we should be good. Save that, close it, and I will see you guys inside KSP so we can make sure everything works out. Okay, so I hopped up in the VAB here to show you something. Now, first off, when you mouse over and you bring up the right-click menu for the parts we edited, we can see that it's there. Because if you look, the Kethane detector on the top is detecting liquid moon. Also, if we head over to Utilities and click on the external drilling unit, it has 2 Kethane extractor modules, and one of them is mining Kethane at a rate of 1.25 liters a second. The other one is liquid moon at 5 liters a second, just like we configured. And if we go to the small converter unit, then we can see, whoop, if I can get that menu to stay, there we go. We can see that we have moonshine right here at a rate of 2 per second, and we also have our liquid fuel and oxidizer, although it appears to be a little bit bugged out. Let me go check on that. Coder's worst nightmare, spelling things wrong. It's supposed to be input rates with an S, not input rate. Control save, close out, and I'll see you back in the game. Okay, so back in the VAB, as you can see now that we have our liquid moon converting into liquid fuel and oxidizer, and our liquid moon converting into moonshine quite effectively. They are now there. However, if you notice, the values are not what we set them as. Now, I just learned this. Now, let me bring this in here. Magic of windowed mode. If you look, our liquid moon densities are at 0.01, and our moonshine density is half that. Now, the liquid fuel is also half that density of our liquid moon. So, when we look at the numbers, we can see they're twice what we set them. We set liquid fuel to be 4.5, and we set oxidizer to be 5.5. Also, with moonshine being half the density of liquid moon, we can see that it is doubled. So do take into account, because I just learned this as well, the densities of your liquids get converted through. So if liquid moon is twice as dense, it will produce twice as much moonshine as you write it out. I guess that's why they call it ratios, or why it is called a ratio in the config thing that we just defined. Anyhow, we have our vessel here. We have our scanner, our drills, and our converter. So, let's go find our way over to the moon. And like magic, we're here at the moon. Now, one thing that is a slight issue, but hopefully won't be too much of a problem, is when you do add the modules this way, you have to make sure you know which detector you're looking at. So the first one, since it was the first module added, is Kethane, or the second one is the one we actually want. And if you add a third module, then they go in linear order. So let's activate the second one. Open up our map view here. Now you can see this is the world we already had. This is where Kethane is already present. And just to confirm, we're not scanning any more land, so we don't have the Kethane scanner on. Let's switch it over to liquid moon. Now you can see we're scanning for liquid moon. And this was me testing earlier, how I found out you can't have 1.0 color values, otherwise it won't work. And if you look, this is purple, it's about 500,000, and over here closer to the blue color is 700,000. So as we get lower in resources, it turns toward the red color that we set, and as we get higher to our max, it turns towards the blue color we set. So now that we've found a pretty good source of our liquid moon, let's see if we can't land. Once we land down, we can test our miners, because we are on our liquid moon. And just because I didn't state this yet, I am using Modular Fuel Tanks. So this is just the FLT100 fuel tank, and this one can hold moonshine, whereas this one down here can hold liquid moon. I just set when you define a resource, Modular Fuel Tanks will automatically set that up for you, and I'll even have a link to that one down in the description just in case you want it. Now, let's take a look at our drills. As I stated before, and will continuously state, check your spelling. Shaft, small geo, is not the transform we need. We need shaft with a T. Save that, and see you back in the game. Now that we've got our problems sorted out, we can now deploy the drill and actually get our liquid moon. So you can see that here I already picked some up. That was me testing to see why it wasn't working earlier. But I got it working now. You have to make sure all of the spelling is right. And there's going to be a link to where you can find the proper spelling of all these. Now in just a couple seconds we should be getting there. We go. Getting our liquid moon from our drill. And at the same time, because both are considered retracted, if we had a container, we could start using Kethane as well, or Kethane, sorry. Like I said, gonna get that wrong. And if we right click on our medium converter unit, then we can see we have the LFTO converter and the moonshine converter. Well, let's click on this one. And as we can see, our power is slowly draining, and our moonshine is going up. Let's turn this off, make sure we have plenty of power. And now we are getting moonshine, which is what our Kerbals will just love. Now, the reason our converter isn't actually going to work is because these two fuel tanks are not hooked up to any way that the fuel can flow from the converter into the fuel tank. Typically, the converter either needs a fuel line from it into the fuel tank or be directly connected to the fuel tank for it to work. And that's because liquid fuel and oxidizer use the stack flow type, not the all vessel. For a quick recap on what we've done, we defined two resources, one known as liquid moon and the other moonshine, said that they both cannot be filled inside of a tank, so that we could not start with them. We had to go out and mine them. We defined resource liquid moon so that it would generate on both the moon and minmus in different quantities, in different deposit amounts. We also learned how to customize the Kethane plugin to customize our Kethane detector to detect our new liquid that we search for, our small drill to mine for the new liquid, and or resource rather, doesn't need to necessarily be a liquid. And we also learned how to define our converter so that it can convert our new liquid into different fuel sources or different kind of story-driven liquids that don't necessarily have any use as rocket fuel. Or do they? Anyhow, I am PTTGRW. This has been your Kethane tutorial on how to add resources and configure the parts to your needs so that you can use those new resources. Do note that if you do want to make a mod with this info, you cannot use the original models, and there's a link to the license in the description that will tell you that you can't. So this is only good for personal use. You cannot distribute any of these that use the original Kethane models, but you can use it for your own use. That is allowed. So I hope I've made your worlds a little bit more interesting with all the new resources you can gain from it. But this is PTTGRW signing off.